Welcome back. Today we're going to talk about charge configurations and how to draw electric field lines properly for a charge configuration. Once again, this is just a way that we think about things and a way that we model the electric field. And so let me go ahead and share my screen. So I have several charge configurations here that I'm going to use as examples. First thing to say is there's likely going to be a 10-point problem on exam 1 with a configuration similar to these. So if you practice a few times, it'll be an easy 10 points, which is always nice. All right, so this first configuration over here, actually, let me partition these off. That way you know which is which. So the one on the far left here is a configuration with one positive charge and one negative charge, and they have equal amounts of charge, just opposite signs. So recall that field lines emanate from positive charges and terminate at negative charges. So the direction of the arrow is important to keep things straight. That's the convention for the model. So there's several proper ways, actually there's infinitely many proper ways to draw field lines. One of them would just be having one field line leave plus Q and terminate at minus Q. Another one would be having two field lines leaving plus Q and two field lines terminating at minus 2. Or 3, and you can kind of keep this going as far as you would like, as long as the ratio is maintained, and the ratio here is 1 to 1. So for every one field line that leaves plus Q, one field line must end at minus Q. And as you may notice, these field lines for this two-charge configuration, they kind of loop in on each other. And what we're used to seeing with like just a 1-point charge that's positive or negative is we have these field lines that are perfectly radially emanating or terminating at the charge. And so we can see that the electric field is more effectively spread over distance with this one positive charge than it is with this one positive charge, one negative charge. And so actually at a distance, so to somebody who is standing, and of course, the electric field drops off as 1 over r squared for a single point charge. But for this dipole here, this one positive and one negative charge, for somebody over some distance away, they may not even be able to measure the electric field created by this dipole, simply because we have a plus Q and a minus Q. And at a distance, the net charge just appears to be Q minus Q. So from a distance, it will be hard to find an electric field that's emanating from this configuration. All right, moving on. Now I have a plus 2Q charge and a minus Q charge. And for this, the rule is for every 2 lines that leave plus Q, one of them must terminate at minus Q. So this is one proper configuration, or one proper way to draw the field lines. Here's another one. Now I have 2 lines emanating or 4 lines emanating from plus Q, and 2 of those terminate at minus Q. So in other words, our ratio is 2 to 1. For every 2 field lines that leave plus 2Q, one of them must terminate at minus Q. And let's draw a few more field lines to kind of give us an idea of what would maybe occur with this particular one. Oh, and it's also important to note that you see how I have 8 field lines leaving plus 2Q here. That means that in the same drawing, if I just had a plus Q, I would have half the number of field lines leaving. So for this drawing I have up here, I have 8 field lines leaving plus 2Q. Therefore, half of that amount of field lines will leave plus Q. So 8 to 4 ratio here. So what you may notice is that at a distance, some distance away, some radius away from these 2 configurations I have drawn, that there's 4 field lines that are kind of escaping radially from the plus 2Q minus Q configuration. And there's also 4 field lines radially escaping from the plus Q down here below. So similar to the last configuration, we see that the plus 2q and minus q configuration, when viewed at a distance, actually appears as though it's just a single plus q charge. So in other words, at some distance, the person wouldn't be able to tell whether this was a plus 2q minus q configuration or if it was actually just a plus q. So once again, the net charge here would be the 2q minus q, just gives me positive q. All right. So for the next configuration, up here in the right upper region here, I have a larger negative charge than I do positive charge. So I have minus 3q and then a plus q. So what that means is that for every one field line that leaves plus q, for every one that leaves plus q, 3 must terminate at minus q. And so this is one possible configuration respecting the ratio of 1 to 3. I could draw another field line from plus q outwards. Then of course I'd have to draw 3 field lines that terminate at minus 3q. All right, and at this case, at a distance, at some far distance, the net charge would appear to be minus 3q plus q, which is minus 2q. And then finally, for this last one, we'll do a configuration of 3 charges. And so the same rules still apply. So for every 3 field lines that leave plus 3q, one of those 3 field lines must terminate at minus q, and 2 of those field lines must terminate at minus 2q. So in this case, you'll notice the net charge of this configuration of 3 electric charges is actually 0, right? Plus 3q, minus 2q, minus 1q. And so once again, this configuration's field lines are going to kind of loop in on themselves. And that's going to make it, that's going to make the E field drop off quicker as you radially go away from that configuration comparative to if you were just radially going away from a single point charge. All right, so I hope this was helpful. Practice a few more of these and you'll be good to go. Thanks for watching, and I'll see you next time.